Hello everyone, this is Mr. Schaefer and I'm so glad you came to watch this little video. The chances are you're watching this video because you need a little bit of help in graphing sinusoids, in particular the sine and the cosine curve in all its variations, and you need a little bit of tutoring for that. So I'm so glad that you came because it's only the smart people that seek out help, and you're obviously one of them. So let me help you a little bit. Okay, let's get started. The first thing I want to remind you of is some of the things we talked about in class. The steps to successful graphing are going to involve two different kinds of activities. We need to gather some information. Let me use my cursor here and highlight that. We need to gather this information, and once we've gathered that information and sifted it a little bit, in other words, calculate the period and determine the phase shift, then we can go on to the second step, which is to graph the particular function. The good news for you is it doesn't matter what kind of sinusoid I give you, following these steps will lead to success, and you are going to do a marvelous job. Okay, let's start with this function. Now, I decided to choose a cosine function, and as you can tell from our discussions in class, you have all of the components in here, the four necessary pieces of information that will help you graph this curve. And as a quick reminder, we have this leading coefficient, which we often refer to with a capital letter A or a lowercase letter a. The next number over is also very important in front of the theta. This will give us some information. We refer to this in class with the lowercase letter b. We've got this next piece inside, which we refer to with the letter C, and then this last piece. Okay, so if you remember the four items of information that we need to gather first, here they are. Let's figure out what we need, and then we can move on to the graphing piece. The first two pieces of information are quite easy if you remember. The first thing we concern ourselves about is the midline. Now the midline is that horizontal line through which the curve goes up and over and down and underneath and back and forth and goes like that, like a regular wave. And we find that at the end, right? That's letter D, and we see here it's -3. And what does that mean for us? Well, it means that the horizontal line, y equals -3, is that midline. Very easy. You can always pick that up. Just as a little hint, once in a while, they'll show this number in the front. So you could see -3 plus 2 cosine and the rest of this. Okay, so just look for the number that's by itself. Often it's at the end. The next is identifying the amplitude. So we denote that with a little letter A, and where do we look for that? Right in the front. So it's right there, and it'll always be there. And again, remember, if there isn't a number in front of the cosine, what that means is that the amplitude is 1. I also put this note on here. Is it negative? Now, I may have to make another video to show you what happens when it's negative. Of course, we've discussed this in class. And what that means is that the function is reflected over the midline, so it goes in just the opposite direction. But that's for another video or maybe a discussion in class. So we've determined the amplitude is 2. That's the height of the wave going up from the midline, coming back down, and then coming back to the midline. The next thing is calculating the period. Now this will take you a little bit of work, not too much though. And here's a reminder. The formula is the period is equal to 2 pi over what we call the letter b. We're going to pull this 1/2 down into this formula, put it here. We're going to execute this little command of taking 2 pi and dividing it by that, and we get our answer. So let's see if you can follow this. This is just straight substitution. 2 pi, here's the half. Now remember, when we divide by a fraction, we have to take the reciprocal of what we're dividing by, which is 2/1, and then we multiply. Our answer is 4 pi. Okay, so we're done. We're 3/4 of the way done. Next, let's determine the phase shift. The phase shift also has this formula. We take -b divided by c. Here it is. What I want you to notice is that every time I'm going to do this, I will put a minus sign out in front. I'll put parentheses here, and inside the parentheses, I put in whatever you see that follows the theta in the parentheses above where my cursor is now. Okay, we've gathered all the information we need to graph. Let's go on to the next step now. The next step is to actually graph. So what I've pulled out are the important points that we need to consider as we graph. I have the equation on the top of the screen, and the first thing I'm going to do is create an x and a y axis for myself. Now, I deliberately do an xy axis in this format only because most of the graph is going to occur here on the right hand side of the y-axis. And in this particular instance, I already know that the midline is at -3, so it's going to be below the x-axis, so I'm giving myself a little more space. Okay, well, let's go to the next couple of steps. First thing I want to graph, if you remember, is to sketch the midline. So where does that occur? That's at -3. And I'm going to use a dashed line to sketch that. The next thing is going to be the maximum line and the minimum line. That's the words, those are that's the vocabulary I'm choosing to use. But these are the two lines, horizontal lines, they're parallel, through which this channel or this sinusoid will flow. Okay, so we've got that. The next thing I'm going to wind up doing is taking the number line, or the x-axis, and I'm going to break it into 4 separate regions. Here's the first, second, third, fourth. And the reason I want that is because when I graph any sinusoid, there are 4 quarters through which it passes through. Now, the size of where these quarters are, where they're located, they all change. But the fact that there are 4 of them never changes. Okay, so now I'm going to start labeling them. And you notice I started with the 4 here. And that's because the period is 4. It's 4 pi to be specific. So then I break up these 4 marks into quarters. So 1/4 of 4 is 1 pi. 2/4 of 4 is 2 pi. 3/4 of 4 is 3 pi. So here we go. We have the 4 different regions it's going to pass through. Okay, next, let's sketch the cosine curve. A quick reminder, I'm sketching the cosine curve prior to the shift. Right? There's a phase shift that's going to occur, but I want to sketch it beforehand so I know where to move the curve later on. And what you also need to remember, and this you just have to either memorize or practice it long enough, you're going to know that the cosine curve always starts at its highest point at 0 before a shift. Then it goes to the midline. Then it goes to its minimum point. Then it goes back to the midline to the maximum. Okay, so what you see from 0 all the way to 4 pi is one complete period. And I have sketched a little more just to give me the idea of how this curve is going to continue in either direction. Okay, we're almost done. The next thing I have to account for is that there's a phase shift of 2 pi. And what that's going to cause is it's going to cause me to add a few more hash marks here so that I can accomplish this shift. So I'm going to move this maximum point, this midline point, this minimum point, this minimum point, I believe that's a midline point, and this maximum point 2 pi units to the right. When I do that, the graph looks like this. We're done. Each one of these points has been shifted over 2 units. And I don't bother with anything in between the midline and the maximum and minimums. I just move 5 coordinates, 5 points to the right or to the left, depending on what this phase shift requirement is. Well, you're done. If you can do this, you can be successful with any sinusoid graph that I give you. I wish you lots of luck, and if you still need a little bit of help, please come and see me. You know you can see me before school, after school, and I'd love to help you. Hope this really helps. Okay, guys, bye.